help us to understand better about functions. And then we can also look at some other data wrangling options because almost every data set that we look at will have some type of data wrangling. Sometimes the best way to do that is, in fact, to define a function and create a new column, which is a function of one or more other columns. So that's where we could go in terms of really expanding what we can probe with our data sets.
I just saw that. I just felt like some of the students didn't have like a full understanding on functions. And I remember when I was first studying computer science, I too like didn't fully understand how functions worked and some of the rules regarding like function use. So here is a function that we defined in lab 9 called fitline. So what this function does is it takes a table, label X and label Y, and then it computes something inside of here, and then it returns an array. Um, the thing about functions is that when you are outside of this function, you're unable to access any of these variables that are inside the function. Whereas noticed like some students were like, oh, why can't I use like a variable that like that's in this function right here? It's because um um whatever you define inside the function kind of stays inside of there, and you can't really access that outside of the function. What you can do though is call the name of the function, for example here, and use this function as kind of like a shortcut to compute whatever is inside your function. To call the function, you firstly need to the name of the function, and then as you can see here, you need three inputs for this particular function, because when you define this function, you put three things here, which means that when you do call it, you need those three things for this function to work correctly. Here I'll try my best to explain it in a more simplified view. Kind of have this here to try to explain this. So if you take Jupyter Lab as this entire light blue box, which is like whatever is in here, whatever is inside there can access each other. Like, so this box, for example, this anything from this box, for example, can be accessed later on in the lab, which is why I think it's a bit confusing when you have a box that now you can't access things inside that. So if we denote these boxes we have here in the normal Jupyter Lab, that where we have our code as these dark blue, kind of similar to the light blue that we have as the entirety. This anything inside the dark blue can access the variables inside the other dark blue boxes, which is why I think it's a little confusing for students sometimes. But what you can do with the is define a function. For example, if I define this function in this green box here, I can later on call it, and whatever's happening in this box will now occur in here based off of the keys. Let's just call them keys, like these three. They're kind of like the keys to the box, which you need to like access this function. So whenever you call this green box with the keys, it will spit out whatever it returns. That's what this part is for. Whatever it's returning, it's what will appear in your blue box now. And this is useful because it kind of acts like a shortcut. Instead of every time I need to uh, find the fit line, for example, typing out all the code for it, I can now just call the name of that function and then put in the specific information it needs, and it'll return the fit line for you instead of having to type it out every time, which is, you notice here I have two green boxes. So here I would just call the name of this green box instead of typing it two times. And same thing with this red box. And that's kind of like a general overview on how functions work. Here I have like a little example, right? So first we define this function called add numbers, and then we put certain inputs in there. And for fit line, for the fit line function we were looking at earlier, right here, you notice how it needs a table, X and a Y. What you're saying is that whenever I use this function, I need these three things. So when we're making it, we're going to use add numbers. And then you notice how the number of things you need can differ depending on your needs and what your function is doing. So for adding two numbers, I only need two things, a x value and a y value. It can be named anything. Um, and what I'm going to do is add these two and save it to a result and then return that result, which is if you don't return it, then you won't see anything. Returning it basically gives you the number, the result back. So as we can see here, if we run this uh, by calling the name of the function and then putting two numbers in, we can run it and it'll give you 6. But again, like I said, you are unable to access anything that's inside of a function um, that's outside of it. See, if I, for example, print my result here, which is from here, you'll still see 6 from the print add number, but you can see an error occurs when I try to print result because what's inside the function stays in there. And additionally, a little bit more about functions is these names can really be anything. Let me see. Hold up. It can be number 1, number 2, and I can have two variables. Number 1 equals 7. Number 2 equals 10. And I can just put the variables inside as well. I think I noticed a little confusion among students where they're like, okay, then does then let's see, print 7. Oh, it works the same way. I think I noticed a little confusion among students where they're like, oh, so does a variable I put in need to be the same name as the one that goes in here, or like what happens? No, this can be any name as long as this is what you're using inside that function. And whatever you're putting inside can be named anything as long as it's the type of information that that function needs. For example, this function needs two numbers, then whatever you put in has to be two numbers. Whereas for, as we can see in here, we need a table and we need two labels. Then whatever you put in has to be a table and two labels. It has to follow the same type of information, but the name of the variables can be whatever you want. So if you change this to A and B, A and B, it will still run the same. It does not have to be the same as the name up here when you're defining that function. That the name you're putting when you define the function is basically just a placeholder for uh, the variable, and it's also what you're gonna be using to denote what that variable is inside the function and only inside the function. So if this is number 1, this will also have to be number 1. This number 1. See, if you switch these to number 1 and number 2, and then you can put A and B. Let's see, all right. It should work like this. Um, so what I was saying is what what whatever this name is what should be used inside that function, and whatever you put in can be anything as long as it's the same type of information. And then basically when you run the function, you should get whatever you return. And that's kind of like an overview on like functions that I know, and some of the issues I saw some students run into, mostly just using things, variables inside the function, or confused about like what they should name things that are going in and out of the function. Yep.
That is so clear. Imagine those listening and watching will really benefit from such clarity. Really like the idea of those boxes and so forth. So certainly when we have this video, it may be useful for students at the beginning of next semester to see some of these ideas.
Yeah.
Because
I remember like I also had trouble with functions a lot too when I first started coding. So I thought I tried to explain it with a little bit of understanding that I have now.
No, that's great in terms of what's local and what's separate from it. Okay, so one of the key things with your projects is going to be a fair bit of data wrangling. And we've done this, but many of the times there's been assistance within the lab to help you get to that point. Let's look here at an example with the Staten Island crash data and see how we can proceed here. So of course, first off, we need to bring in several of these modules, including data science and numpy. Then we can load the data. So here we have the data set in example 3 rows. Now I'm going to limit the data to the rows that I'm most interested in at the moment. So here it's a little bit less complicated. So now what I would like to understand is by zip code, both the number of persons injured and the number of people killed, but not only the numbers, but also the numbers relative to the population. Now, the population is not originally in this data set, but we can use a second data set to get that type of data. So this is referenced at the top of the project data set. And so here we can see by zip code the 2010 population. So these are the numbers associated with those zip codes. And these are not in thousands, these are actual numbers like 18,570. The only thing we note down here is when we look at the zip code, we find out that the zip code, as with other data you may find in your data set, is actually in a string. So being in a string, the presentation of the data is very nice within the table, as we see it here. But the problem is we may not be able to use the join command here. So what am I trying to do? I am trying to take from this crash small table and match the zip code here with the zip codes over here in the US population by zip code. So the problem is these zip codes are in strings, and these zip codes, though it's not obvious, but we could explore it in more detail, these are actually numbers, okay? So oftentimes you will see this kind of problem. So if I try to join, so this is the table, data science table join command, and the way you use that command is this is the column from the original data called crash small. That's the original table that we looked at up here. This is the zip code column here, and we want to match it with the zip code column in this zip pop data set. So if I do so, we wait, and in fact, there's no output. That indicates that none of the rows of the original table were matched with the other table. So it might be deceptive. You might have thought something had occurred there, but because I'm doing this and not storing this somewhere, I should have seen some output. So here we can diagnose the problem. Here we see the crash small zip code. Given these dots at the end, this indicates that these are actually floating point numbers being used here. So one way to deal with this is we can take this column from zip pop, which is this column here, and we can remove this for a moment. and we can display it in this manner. So here you can see these numbers are consistent with what we see in the zip code, zip code from the crash small. Now, this astype is not something that we've covered before, but these are the kind of tips that we can give you as you're encountering challenges in the project. So be sure to ask, but this video does provide you with some ideas. So here, this is a very efficient way to change the format from the string to the floating data point. So now if I put this piece back and store this in an array, I can easily put this array back into the table using the with columns method. Okay. We can look at the zip pop, short for zip code population. And now you see the fzip, you can see the difference. So here you get the 00601, but of course, those leading zeros are only possible with a string data type. So now if we join, after a short wait here, we can see, in fact, the zip code and population have now joined in to add additional rows to the original crash small data. Okay, so that's the benefit of what we've just done. So now if we want to group by zip code, what we can see, while this does not bring the population in, this is the count of incidents by each of these zip codes. There's another way we can use group by applying additional numpy functions to the table. So this is a very valuable approach. So here, for instance, I have computed the sum of the number of injured persons and unfortunately the number of persons killed in accidents in each of these zip codes. So here, that's the power of using the group and adding the NP sum here. If we go forward with the zcrash data, and here, now I can join to this zcrash, because note here the population doesn't show up because the NP sum does not function with the data provided there. So now if I attempt to rejoin, now with these injured people, I do have the population associated with each of those zip codes. So now the final piece that I'll show you is we can create a new column in the zcrash, and that new column would be the number of people injured per population, okay? So you would take the number of injured persons, note that there's the sum here because we use the NP sum, divided by the population. And unfortunately, if you look carefully at the population, you would find that this, even though these look like numbers, these are again strings. So here we need to use this astype float, much like we did before. So what do we get from this command? Now we get a very nice number here, which can show, for instance, in this zip code, we see that there are, the injury rate is about 5%. Okay. Why do I say 5%? Because the physical number is 0.056. So might even be, if we rounded it, 6%. In this zip code, it's about 1%. And then this zip code is even lower. So there's something about this zip code which is particularly high. Last little piece I can show you is we could sort this column, okay? So to do that, we could put the column name here. And here we could say sort, no, it's ascending equals true, okay? Or descending, I'm sorry, not ascending, descending equals true, okay? So now we see that indeed these couple zip codes here have the highest number of injuries per person, okay? So this is an example. Yes, there is a group working on the crash data, but this isn't a question that they're specifically looking at. But I think the use of this data is relevant in terms of demonstrating both the group and the way in which we can join two tables, this dot join. We only use this a little bit in the first mini project, that is the dot join. And the new thing that we're covering here in this video comes to play because of the nature of the data. That is, we found that this zip code data was originally a string. So when we tried to do the join this way, we found that the string values were not consistent with the float values. So we needed to create this fzip. This would be an array where we converted these to floating point numbers. And then we could add this back in and get a new column. So thank you for your attention.